Alright, we're back and we're still focusing on motion. The section that I did about motion in, well, the several videos that I did about motion in one dimension, I hope you've had a chance to watch all those, and I hope you've been working on your homework at this point and are starting to get an intuition for how to choose which equation, and the idea that there are more than one ways to skin a cat. You know, there's more than one way to solve a problem too. So now, you know, we kind of covered vectors and scalars earlier on. I wanted to zoom in a little bit more on vectors because I explained vectors as components, or vectors as angles and magnitudes. I think that was like video 3 or 4, I can't remember. But now I want to talk about adding vectors together, which we kind of discussed in the video vectors and scalars, but not as much directly or visually. So I want to go ahead and start in the two-dimension, the XY plane. So I'm going to go ahead and draw my XY plane, and I'm going to call this video vector addition and subtraction, which of course subtraction is just the inverse function of addition, and so they undo each other, and so they are kind of similar in how they function. Let's go ahead and draw one vector right here. We'll call it V1. And that doesn't necessarily stand for velocity one. I'm just choosing V for vector. So this could be representative of displacement, velocity, acceleration, any vector that we've learned about so far. And then let's have this other vector here, we'll call it V2. And hopefully this pen's visible to you. It's a red pen. V2. Alright, so one thing to note about vectors. So, you know, you may be familiar with ordered pairs on an XY plane, like for example the ordered pair, let's say 2, 3. So that means I would go 2 on the X, 3 on the Y, and that's the point where I'm at. Well, the thing about vectors that's kind of interesting is although you can apply them to any given point in space, they mathematically always start at the origin. So where X and Y is 0, we call that the origin. And vectors always start at the origin. Once again, you can move them around mentally, but the way they are as mathematical objects, they will always have their tail firmly centered on the origin. So vector 1 and vector 2 both have their tails firmly on the origin. And let's go ahead and say that V1, and we're going to write it in the X hat, Y hat, Z hat notation. And then, I mean, it's really up to you. I'm not sure where Ahab is leaning right now. I think he may have been using IJK and now he uses XYZ. Anyhow, there's unit vectors, right? We discussed this in the video, on the video about vectors. So if you haven't seen that, I recommend watching it. So let's, for example, say, let's say that both of these are 2 unit vectors in the X hat direction. They both look like they're about the same amount in the X hat direction. And then up here, let's go ahead and say that vector 1 is 3 Y hat unit vectors along in the Y direction. So V1 is going to be 2 X hat plus 3 Y hat. And if there is another way to write this, it's really up to you. I'm not sure why they chose IJK, but you can write it like this as well, with IJ and with I and J for the X hat and Y hat unit vectors. So it's really your choice. I normally use IJ and K for X, Y, and Z, but I think for the sake of these videos, I'm just going to stick with X hat, Y hat, and Z hat, just because it seems a lot more intuitive. All right, so V1 is 2X hat plus 3Y hat. That's its components. v2 equals, we decided on 2x hat. And let's kind of draw it a little differently so that it has a whole number in the y hat. So 2x hat, 1y hat. Alright, now if I wanted to add these vectors, we kind of did this in the last video, right? Well, not the last video, but the video about vectors and scalars. We just add like components. Because remember, these two directions, the x direction and the y direction, are orthogonal, which means they're at a 90-degree angle. And there is no way to add things that are at 90-degree angles, because y is going in a totally different direction than x. And so we have to add like components. 2x plus 2x, 2x unit vectors plus 2x unit vectors equals 4x unit vectors. 3y unit vectors plus 1y unit vector equals 4y unit vectors. And remember, the unit vectors are length 1. We make them length 1 because multiplying anything by 1 doesn't change it. So all that the unit vectors do is they maintain direction. In other words, they're just guides. They tell you which way the x-axis is going, which way the y-axis is going, and which way the z-axis is going. So anyways, we've now added these two vectors, and so the sum of vector 1 and 2 equals 4x hat plus 4y hat. But what's the visual interpretation of this? So the visual interpretation of this is, I want you to imagine that we're going to take, let's go ahead and take v1, okay, and we're going to stack it. We're going to stack it at the tip of v2. So we call this tip to tail, right? Because I'm taking the tail of v1 and I'm putting it on the tip of v2. And that looks something like that. So in other words, I've just drawn v1 again. Remember, I said that vectors mathematically are always rooted at the origin, but we can move them for mental reasons, you know, just to visualize things. And then, of course, you'll notice if I take v2 and I stack the tail of v2 onto the tip of v1, I'll end up with another v2 up here. And then what we're going to do is we're going to start from the point where their tails are starting together to the point where their tips end together, and that is representative of our new vector. I'm drawing it in black, and that vector is indeed vector 1 plus vector 2. So this black vector is vector 1 plus vector 2. What you may notice is that this actually makes a parallelogram, right? So in other words, this side's parallel with this side's parallel with this side. This side has the same length as this side, and this side also has the same length as this side. So vector addition is always going to appear as a parallelogram. So that's the addition right there. Let's go ahead and look at what a subtraction looks like. So we'll keep v1 and v2 the same, and get rid of v1 plus v2. Alright, so what you may have noticed is that based on this, if we take v2 plus v1, so in other words, I'm doing the operation backwards. Instead of doing v1 plus v2, I'm doing v2 plus v1. I actually end up with the same solution. You know, for example, just like in a regular number line, if you take 2 plus 3, that's equal to 3 plus 2. But if I take 2 minus 3, that's not equal to 3 minus 2. One of them is actually going to be the negative integer of the other one, or the negative number of the other one, I should say. Alright, so what happens when I take v1 minus v2? So v1 minus v2, that's 2x minus 2x, that's 0 in the x hat direction. 3 minus 1 y hat unit vectors is 2 y hat unit vectors. And you may notice that this vector goes 0 on the x and minus 2 on the y. And then you'll also notice that if I were to draw that vector out, it's going 0 on the x. Let me draw it with green. So it starts at the origin because it's a vector. And it is actually lying on the y-axis, and it's going -2 on the y-axis. Now I can take that vector and move it for conceptual reasons over here, and put its tail on V1's tip and its head on V2's tip. And what I'll end up with is a vector that points from the tip of V1 to the tip of V2. And so you'll notice that if it's V1 minus V2, then the arrow starts at V1 and points at V2. Now let's do V2 minus V1. Alright, V2 minus V1 is going to give us 0 again. This 2 minus 2 is still 0. Now we're taking V2 minus V1, so 1 minus 3. Oh, I'm sorry. V1 minus V2 was positive. I did that incorrectly. Alright, so because V1, we take V1 minus V2, that gives us a positive 2. So in fact, V1 minus V2 would be a vector that looks like this. It would be 2, positive 2 in the y-hat direction. So V1 minus V2 points from V2 to V1, whereas V2 minus V1, right, V2's 2x minus 2x is 0x. 1 y-hat minus 3 y-hat is minus 2 y-hat. Minus 2 y-hat. And so that would be a vector that looks like this. And that would be pointing from the tip of V1 to the tip of V2. So if you have V1 minus V2, it's pointing from V2 to V1. If you have V2 minus V1, it's pointing from V1 to V2. But both of them are going to have the same magnitude. It's just the direction is going to be exactly opposite, depending on which one you subtract first. Which kind of makes sense because, like I said, 3 minus 2 equals 1. 2 minus 3 equals minus 1. 1 and minus 1 are perfect opposites of each other from the origin, and so it kind of makes sense. It can be kind of hard to remember, but you don't really have to, because you can always just subtract and figure it out, instead of memorizing, for example, that if you have V2 minus V1, it points from V1 to V2. It's kind of the backwards, so if it's V2 minus V1, the vector points from V1 to V2. And that's just about it for vector addition and subtraction. The reason why I'm doing this video now is because at some point we're going to be hopping into motion in 2 dimensions, and at that point, because remember with motion in 1 dimension, everything was on the x-axis. So we never had to worry about actual vector addition, because every vector we were using was all x-hat vectors. And so we were just hanging out on this single line. And so we never really had to worry about how to add different components. Well, now that we're jumping into 2 dimensions, we're going to have to be sure to be careful with our kinematic equations and keep them separated between the y and the x-axis. So anyways, I'll see you next video, and I hope this was helpful.